morning, sir. Today we will be talking about principal pitch propeller. A controllable pitch propeller is one where... Baliktad, that's so good. Okay. 1, 2, 3. Good morning, sir. Today we will be talking about principal pitch propeller. A controllable pitch propeller is one where the pitch is controlled manually by the pilot. Alternatively, a constant speed propeller is one where the pilot sets the desired engine speed RPM, and the bladed pitch is controlled automatically without the pilot's intervention so that the rotational speed remains constant. The device which controls the propeller pitch and thus speed is called propeller, governor, or constant speed unit.
When an aircraft is stationary with the propeller spinning in calm air, the relative wind vector for each propeller blade is from the side. However, as the aircraft starts to move forward, the relative wind vector comes increasingly from the front. The propeller blade pitch must be increased to maintain optimum angle of attack to the relative wind. The first propeller were fixed pitch, but these propellers are not efficient over a range. Performance: the propeller will be inefficient in cruising flight because the blade will be at the low an angle of attack. In constant, a propeller set for good cross performance may stall at low speed because the angle of attack is too high. A propeller with adjustable blade angle is more efficient over a range of conditions. A propeller with variable pitch can have a nearly constant efficiency over a range of airspeeds.
Engine oil pressure is the usual mechanism used in commercial propeller aircraft, and the Continental and Lycoming engines fitted to light aircraft. In an aircraft without a constant speed unit, which is CSU, the pilot controls the propeller blade pitch manually. Alternatively, or additionally, centrifugal weights may be attached directly to propellers which were called counterweights propeller, which were driven by mechanisms that operated on centrifugal force. The operation is identical to centrifugal governor used by James Watt to limit the speed of steam engines. Eccentric weights were set up near on the spinner, held in by a spring. When the propeller reached a certain RPM, centrifugal force would cause the weights to swing outwards, which would drive a mechanism that twisted the propeller into a steeper pitch. When the propeller slows down, the RPM should decrease enough for the spring to push the weights back in realigning the propeller to the shallower pitch.
A constant speed is a variable pitch propeller that automatically changes its blade pitch in order to maintain a transitional speed. Regardless of the operational conditions of the aircraft, this is achieved by use a constant speed unit or propeller governor, which automatically change the propeller blade pitch. Most engines produce their maximum power in a narrow speed band. The CSU allows the engine to operate in its most economical range of rational speeds, regardless of whether the aircraft is taking off or cruising. The CSU can be said to be to an aircraft what the continuous variable transmission is to the most transmission on is the motor car. The engine can be kept running and it is optimum speed regardless of the speed at which the aircraft is flying. Through the air, the CSU also allows aircraft engine and design to keep the ignition system simple. The automatic spark advance seen in motor vehicle engines is simplified because aircraft engines run at a roughly constant RPM. Vertically, all high performance because aircraft engines, propeller-driven aircraft have constant speed propeller as they greatly improve fuel efficiency and performance, especially at high altitude.
Add a little bit of the B to the first attempts at constant speed propellers were called counterweight propellers, which were driven by mechanisms that operated on centrifugal force. Their operations is identical to the centrifugal governor used by James Watt to control the speed of steam engines. Eccentric weights were set up near or in the spinner, held by a spring. When the propeller reaches a certain RPM, the centrifugal force would cause the weights to swing outwards, which would drive a mechanism that twisted the propeller into a steeper pitch. When the propeller slows, the RPM would decrease enough for the spring to push back the weights back in, realigning the propeller to the pitch.
Operation in a single engine. Reciprocating aircraft is as follows. Engine oil is pumped through the propeller shaft by the governor to push on a piston that drives the mechanism to change pitch. The flow of oil and the pitch are controlled by a governor consisting of a gear-type pump, speeder spring, flyweights, and a pilot valve. The gear-type pump takes engine oil pressure and turns into a higher pressure, which is in turn controlled in and out of the propeller hub by the pilot valve, which is connected to the flyweights and a speeder spring, which presses against the flyweights. The tension of the spring is set by the propeller control lever, which sets the RPM. The governor will maintain that RPM setting until an engine overspeed or underspeed condition exists. When an overspeed condition, the propeller begins to rotate faster than the desired RPM setting.
The first practical controllable pitch propeller for aircraft was introduced in 1932. The French firm Rasher produced a variable pitch propellers of various designs from 1928 onwards, relying on a special ball bearing helicoidal ramp at the root of blades for easy operation. Walters S. Hoover's patent for a variable pitch propeller was filed in the U.S. Patent Office in 1934. Thank you, and that's all for our report.